Okay, this is our first lecture for BUSN 231, Introduction to Business Statistics, and today's lecture we're going to spend talking about tool that we're going to use in this class, which is going to be a software package called R, single letter R. So now to be clear, all the materials for this course I'm going to post on the Blackboard, so you have to go to the Blackboard and to the shell for this course. So lecture notes folder will contain PowerPoints. Data sets folder will contain all the data files that we're going to be using. So well, you will see as we go through the lectures, you will see that it's really very simply organized. Okay, so let's go back to the lecture. So today, what I'm going to do in this first lecture is to talk about software tool, which is not really traditional way to start the statistical course, but as it happens, R can be a fairly involved program for especially for people who never did any programming. So therefore, it's kind of important that we'll learn that that tool. So this is where I wanted to start. So let's discuss what is R. R actually is both a program and a language for this program. So the software package R was started in early 1990s, and originally it was just one of the many software packages for data analysis, for statistics. And that's what essentially we're going to be actually using this program for in this class. But over the years, R grew in size and also it expanded its capabilities. So let me kind of touch a little bit on how else we're using this program in other course. So in the School of Business, we have another course called Introduction to Data Analytics, and we're using R in this course as well. So since this package was around for almost 30 years by now, why is it so popular? The reason for its popularity is because it's open source and it's free. What does that mean? Well, that means that the program was created by actually a group of enthusiastic people who like do programming and who like statistics and data analysis. So there is no company behind that that software. It's all done by the community of programmers and statisticians. So let's take a look at how you can get that program on your machines. So this is what you will need to do actually, because we're going to use this program day in and day out. So you have to do is, let's see if I can get it down. Yeah, go to Google and simply type one single letter R. And the very first thing that you will see is project for R, the project for statistical computing. So go ahead and click on that. All right. So go to the CRAN download. Okay. And what you will see is mirror sites. What are the mirror sites? These are essentially servers scattered, you can see, throughout different countries all over the world. And each server is configured identically, so it doesn't really matter where you're downloading that from, but I would pick close server that is closest to us, I mean geographically. I don't know, for example, Iowa State University, this one right here. So you just have to click on the link, and you can download it both for Windows or for Mac. So it runs both on Macintosh, iOS platform, and Windows. So I already downloaded and installed it, so I'm obviously not going to do it. Well, let's actually see what happens. So install R for the first time. That's what I'm going to do, and download R 4.00 for Windows. So you have to click on that one, and you can see that download begins right here, and that's going to be an executable file. So once the program downloads, and it's going to take you a while probably, Right there it says it's 84 megabytes, so it's fairly sizable program actually. So after that you have to double click on that program right here in the lower left corner, and it will offer you, well, let me go ahead and do that. So then you will say run. After that it will offer you the choice of language, and you just basically go through the steps. So since I downloaded and installed it already, I'm not going to do that. So this is one thing that you need to do, and another thing is this. We're going to actually not use the R directly. We're going to use something that's called RStudio. RStudio is a very comfortable development and code writing environment for R. So to find that, all you have to do is type RStudio, and the very first link again that will show up is going to be, well, RStudio. So go ahead and click on that one. Let's see if we can find that products on the top. Then there are several of them, right? RStudio and RStudio Server. So we need RStudio and desktop. So there are, as you can see, two different versions, right? So you can get free version, pricing free, and that's called open source edition. And then there is RStudio Desk Pro, professional version of the same thing, and it costs $1,000 a year. Obviously, you don't want to do that. We're going to do we're going to go with RStudio Desktop. So we have to click on that one, and then after that, just click download. Download for Windows. Okay, so here actually, let me kind of show you. if you're running Windows machine, then this is your link really. Okay, but if you're running Macintosh, then you have to go with that one. So let's see what happens if I click on the download. Yeah, the program starts downloading, and I'm going to have to do the same thing again. So this one is actually even bigger, 150 megabytes. So it will download in just 1 second. Right there, it's done, finished. Okay, and then you do the same thing. You double click on that icon, and in my case it shows I need to run that as an administrator, so you would have to do the same thing, but essentially it's the same process. You have to kind of keep clicking, agree, yes, and then after that it will install in the default location. All right, so let's switch back to the lecture. Okay, so that's the software that we're going to use. All right, so let's kind of briefly discuss how R works. R is not the only package that we can use in order to do the statistical analysis. There are multiple packages. For example, there is SAS, JUMP, then Excel, of course. A lot of universities actually use Excel in order to teach statistics. And there are programs such as Minitab, SPSS, etc., etc. So a lot of these programs for statistical analysis, especially things like Minitab or SPSS, they offer you very nice interactive environment. So you can use your mouse in order to go to the menu, pick the right option from the menu, and then you can just click on the names of the columns and do the analysis. R is not like that. So R is not point and click environment, it's command driven. What that means is really you need to go ahead and type commands, as in computer program commands. So essentially we're going to be writing small pieces of code, small scripts, in order to perform statistical analysis. They are not complicated at all. So as you will go through the semester, you will see that they're fairly standard, and it's not very difficult to memorize them. Plus, another thing is, I'm not going to make this course about programming. So yes, you will learn how to program. Well, essentially the very basics, the very elementary things about programming, writing programs on the computer, but this course really is about data analysis. It's about doing statistics on the data sets. So therefore, I'm not going to make you memorize computer commands. You will be able to use reference as we go through examples, homeworks, and tests. So why R is so popular? And R gained popularity. So as I told you, it was introduced in early 90s, and since then actually it became very popular, especially for something that's called data analytics. So not exactly the statistics that we're going to be doing this semester, but something even more advanced, which is called data analytics. It became popular for a number of reasons. First of all, as we discussed, it's free, right? There is no single company behind this package, so therefore anybody can download it and install it on their machines. It's basically free from payment. That was not a small factor in the popularity of this package. Another reason why R became so popular is driven not so much by the statistics that we're going to do this semester, but data analytics applications. The fact that this package was developed by a group of programmers, which are essentially contributing their work for free. They're not being paid, they just do it because they like doing programming and they like data analysis. The package was expanding very rapidly, especially in the last 5 to 10 years. So a lot of researchers, programmers, statisticians, as they were writing code, they were also creating packages, so libraries that can be used in order to perform certain statistical analysis. And normally after these people were done with their code, they made it publicly available, again through the same CRAN website. So essentially anybody could download their library and use their work in order to perform their own statistical analysis. So therefore R essentially is not as much a standalone product that can do certain statistical analysis, but it's ever expanding set of tools and libraries that are essentially contributions from people all over the world to the ecosystem, so to speak, of different instruments that can be used to perform all kinds of analysis. So therefore essentially R is so popular because it is very powerful in terms of statistical calculations and data analysis that it can perform. Alright, we will learn actually how to do several things in R. How to perform elementary analysis, such as, for example, finding mean, mode, median, standard deviation. And then we're going to do very basic graphs using R. So it's not that much different actually from what you can find in Excel. Excel also can do graphs very easily, but you can do at the same time charts, basic charts such as bar chart, histogram, box and whiskers plot, scatter plot, etc. using R. So we're going to look at how R, the very basic R, can do these charts. And as I told you, R is expandable. That means that actually there were a lot of packages created that can do very sophisticated graphs, interactive graphs that can be published on the websites. So packages such as RShiny can be used to publish, for example, graphs on the internet. We're not going to do that in this course because it's just an introduction, but just to give you an idea, there were a lot of different packages that can allow you to create very sophisticated, very detailed charts. Alright, so RStudio, well, we discussed that, right? So you can download the RStudio on your machine, so you have to do it. So again, reminder, two things, right? You have to download R by itself, and you have to download RStudio. All the code that we're going to be writing, we're going to write that in RStudio. We're not going to use R itself. We're going to use more user-friendly tool, RStudio. Alright, so now let's take a look at RStudio actually. So what I did here is this. As I downloaded and installed RStudio, it created an icon on my desktop, and an icon looks like that. It's just a circle with a letter R inside of that. So when you double click, RStudio loads, and there it is. Okay, so I'm going to make it full screen. Okay, so first things first. There are actually 4 windows to 4 different windows in RStudio, and here you can see actually only 3, right? 1, 2, 3. So let me go ahead and create a new script. So each time when we're going to perform statistical analysis, we're going to start writing a new program. So every new problem will initiate a new R script. How do you create a new R script? Well, you can go from File, New File, R script, or there is a shortcut right here. There is a plus sign, and if we click on this small arrow that points down, the very first one, going to be R script. So that's essentially how we're going to start doing each and every problem. Start a new R script. Bam. And now it creates actually a new window right here. So let's discuss what these 4 windows are. This is going to be our editor window. So in this window we're going to create, we're going to write line by line our program to analyze the data, to manipulate the data. Console is where you can see the results of the execution. So for example, let's say here I want to write to calculate sum of 2 numbers. Okay, the code I'm going to write here in this window, in the editor window. Then I'm going to press run button, and the results are going to be visible for me in the console. So third window is environment. I don't really find it particularly useful, quite frankly. The environment, for example, shows you all the variables that you have created in your script. Well, we're going to talk about that more pretty soon. And then also it has the history. So here's everything that I actually ran up to that point. Okay. So again, I don't find this window all that useful, quite frankly, and probably this is the least used window for me. Now the last part of the RStudio is this one right here, and you can see actually a few tabs. So one of them is plots, for example. Every time when we want to create a plot, it will show up in this area, in this window. Packages gives you a full list of installed packages, downloaded and installed packages. So I just told you about 5 minutes ago that one of the reasons why R is so popular and powerful is because you can download packages that were created by somebody else, install them on your machine, and use them in your code right here, right? And then we're going to use help actually a little bit, just to give you an idea how you can, if you're not familiar with certain things, like for example, I don't know how to plot the histogram, how to use the histogram function, you can always find out by calling help. Okay, so that's the basic intro to RStudio. All right. So, and that's what I have on the slide. So editing, editor window, scripting, then the console where you see the results of execution, variables, and the plot/help. Okay. So let's get started with very simple material. So let me switch back to RStudio. Comments. Leaving comments behind is a very useful practice in a lot of programming languages. So what are the comments? Comments are lines, commands that are simply ignored by the computer. And the reason why programmers, coders leave comments in their code is because they want, well, first of all, for documentation reasons. Okay, so I can write certain script today, and then in a week I'm going to open up my own script. I may not remember what each and every line does. Sometimes it's obvious what the line does, sometimes not so much. So therefore, comments are pretty much pieces of documentation for myself primarily, or maybe for somebody else. Let's say I write the script, the program for R, or any other programming language for that matter, and then I'm going to send that to somebody else, to one of my colleagues, for example, right? They don't know what I've done, right, in this code. So therefore, I may decide to leave comments as the way for them to kind of read and understand what is going on. So in R, the comment line always starts with a pound sign. So if you write the pound sign, and then after that you can type anything you want, because as I said, this line will be completely ignored by R. So this line is a comment, okay? And the way how I'm going to run my programs is right here is the run button, okay? So I can highlight the whole line and click the run button, or I can just click anywhere in the line and click the run button, or I can just put the cursor, click at the end of the string of the line and click the run button. Doesn't really matter, it's all the same. So when I click the run button, you can see that execution, nothing happens, right? So this line is completely skipped, completely ignored. Now what will happen if I would remove the pound sign? Okay, then this would be seemingly a legitimate command for the R, right? So therefore, since the computer will not see the pound sign at the beginning of the line, it will try to actually run this line, but this is just a nonsense, right? So computer will not understand what's going on. So when I click run, you can see it says error, unexpected symbol in this. So basically what it says is, I don't understand what you're trying to do here, my man. Okay, so therefore I'm going to put back the pound sign, and this line, as you can see, is ignored, right? This line is a comment. So it's kind of fairly important, and as we're going to go through the examples, I'm going to show you more cases when we're going to need to leave some comments behind. Alright, so what can I do with R? Well, R, I can use that as just basically a big fat calculator. For example, 2 plus 3. And again, how I run the program is I can just go ahead and highlight the line or just leave it as is. So what essentially what happens is our studio looks at the line where the cursor is located and executes this line. So I'm going to click the run button, and you can see right here that's actually a legitimate command, 2 plus 3. So I'm telling the program to add 2 and 3, and the result is 5. Okay. Now another way how I can actually run the lines is by simultaneously holding down Control and hitting Enter button. So let me illustrate that. Well, you will not be able to see that because it's a video of my screen, but let's say 10 divided by 5, right? 10 divided by 5, and I'm going to hold down Control and hit Enter, and you can see at the bottom in my console 10 over 5, the result is 2. Okay, so this is where I write my programs, where I run them, and console is where the results of the execution are being shown. Okay. Alright, so now let's take a look at something a little bit more sophisticated. Okay, so we're going to go straight with our lecture notes. Pretty important idea in any programming language is an idea of a variable. So what's a variable? Variable is a space in the memory, in the computer memory, where I record something. So I'm storing something in the computer memory. That something in our case can be data. In fact, that's what we're going to do, right? We're going to work with data in this course. Statistics is the science of working with data and making sense out of that. Okay, so let me give you an example of what the variable can be. So let me first of all tell you that RStudio is case sensitive, and R is case sensitive. So that means that how I name my variables is actually important. So here I'm defining variable which is called X, okay, and this is uppercase X. All right, so and I'm going to record into the variable X the value 5. So there are two ways how I can do that in R. Record the value into the variable. This is one way, which is a little bit weird. Okay, it looks like an arrow pointing towards the variable name, right? So my variable is called X, and this arrow says record into the variable x value 5. And see what happens. So if I run this line, and again, running the line in RStudio is just holding down the control and hitting the enter button, right? So you can see that in my environment window I have a new record right here, right? It says x, capital X, 5. So I define the value 5 and I assign the value 5 a name. So essentially the whole idea behind a variable in any programming language is inside the computer memory I allocate a box, if you will. Okay, so it's a storage where I keep stuff. So in my case I keep value, a single value 5 in the box. Okay, but I have to have a way to access that variable, right? To access the number 5 somehow. So therefore what basically does is it says, this line says allocate a box, a certain amount of space in the memory, record number 5 inside of that space in memory, in the computer memory, and give it a name x. Okay, so x essentially is a name that points to a certain box, a location, space inside the computer memory that just stores the value 5. And here's how I can access, so read back from the memory, right? So my computer now remembered that there is a value 5 and it's recorded somewhere. How can I read it back? How can I access the value? Very simple. All I have to do is just type x and either control enter or just simply hit the run button, and you will see that in the console it will say what's inside of x. It's the value 5. So that's essentially a very simple concept of variables. Okay, so anything that I'm doing, I'm working with the data. Data must be sitting in the memory somewhere, right? So therefore I have to record the data in the variable first, and then after that I can do all kinds of manipulations with that data. I can find averages, I can find standard deviations, I can calculate how many certain values I have. I can do whatever I want, right? Okay, so this is one example where I can record a numerical. 5 is a number, right? I can record a numerical value inside the variable. How about I'm going to record 5.3? Can I do that? So I'm going to run this line again, and I want to show the program to show me what's inside x, so I'm going to run this line, and it says 5.3, right? Okay, so I can record numbers or I can record decimals. How about other things such as text? For example, let's say now I'm going to define a new variable. So actually, you know what, let me go ahead and leave some comments, right? This line is comments. Record a number 5 in the variable capital X. R is case sensitive again, right? So here what I'm going to do is this. I'm going to put a comment, comment. So pound sign, record a string or text, right? Text, and that text is hello into variable lowercase x, and that's going to be different from uppercase x. Okay, so and let me show you actually a different alternative way how I can write values into the variables. So here we use this arrow pointing from the value into the variable, right? And alternative way is just simply say equal. They're the same essentially. Okay, so you can do it either like this by typing less than and then dash, so arrow, or you can just say equals, right? So here I'm going to type a text. Text is so every time when you type text values or strings of characters, you have to enclose them in quotation marks. I believe it doesn't really matter if it's double quotes or single quotes. And you can see that as I start typing, I put one single quote, it immediately puts the second one, because the program knows that once you open quotations, you have to close them at some point. And then it places the cursor in the middle, so I can just type hello. So this way, inside the variable lowercase x, I'm going to record 5 characters, HELLO, right? So in this window, in the environment, you will see that I will have a new record. Instead of uppercase x, I will have a lowercase x. So here, I'm going to just run this line, right there. Okay, lowercase x, quotations, hello. So that tells us that this is not a number, it's a string, right? So again, I can type it, lowercase x, and you can see that lowercase x has hello right here at the bottom, right? And what happened to the uppercase x? You would have to guess. The answer is nothing, still there. Okay, so if I put my cursor on this line and just run it, it'll tell me that, yeah, your uppercase x still has the value 5.3. So uppercase x and lowercase x are not the same. They're actually different variables. Okay, so to review, I can record inside the variable number, can be either integer or decimal, can be positive or negative, by the way, if it's minus 5.3 and if it's minus 5.3. It can be text or string, and there is another type of variables, is something that's called Boolean or logical type. So I'm going to put a comment here, record a logical or Boolean, double O, Boolean value true. So Boolean value, logical value, takes only two different values. It's either true or false. And in R, both of them have to be all caps. So all caps true or all caps false. Okay, so record a logical Boolean value true into a variable, let me call it y, lowercase y. Okay, so over here I'm going to say lowercase y. Again, you can either say arrow, or you can just say equal, doesn't matter. So I'm going to keep it equal, and no quotations this time around. I'm going to say true, all uppercase. And you can see that it was, once I typed it, it's highlighted blue. That means that R actually did recognize that this combination of characters, uppercase TRUE, is a special keyword. So that's something that's reserved, that's something that R is familiar with. Okay. So what happens if I will replace them with lowercase? You can see that it's not the color is not blue, right? So if I run that line, it will not understand me right here. Error, object true, not found. So it doesn't know what is that I'm talking about. But if I make it true uppercase, after that, when I run this line, it creates a new variable, records the value true inside of that, gives it the name y, and that actually shows up right here. You can see that it's part of my, it's a listing of the variables essentially. That's everything that I have running in my memory right now. So lowercase y is the name of the variable that currently has the value true. Now I have to point out that this is not a string, okay? Even though it looks like it's a string, but it's not. Okay, so true, the value of true oftentimes in the world of computers is associated with the number 1. So false is 0 and true oftentimes is 1. So you can think of logical or Boolean variables as integers. So it's a special case of numerical variables essentially. You can think of them as integers that can only take the value of 0 if it's false, or value 1 if it's true. Okay, so and now if I go ahead and type it out, I'm going to say lowercase y, please show to me what's inside. You can see that at the bottom right here in my console, it did type out the value true, but note that here when I asked for the lowercase x, it typed hello in the quotation mark. This time around there are no quotations mark. That means that it's not a string, as we just discussed. Okay, and just for the heck of it, let's actually do this. I'm going to define variable z, and in this variable z, I'm going to record false. You can see that it's also uppercase, and it's all highlighted in blue. That means that R actually did recognize that one also as one of the special keywords. So I'm going to run this one, and you can see that z is added to the listing of my variables which are current. Okay, and if I want to type out what's inside variable z, it's right there at the bottom, false. Okay, so this is introduction into variables. Essentially, we're going to be doing using a lot of variables as we go, so you will get used to the idea. Okay, so we just discussed this example, right? How do you record a number 5 into the variable? You can use either equal sign or a less than dash arrow sign, which is also an assignment operator. It can be decimal. You can write into the variable either a number, right? It can be integer, decimal, positive, negative, whatever it is, doesn't really matter. It can be a bunch of characters such as hello world, or it can be logical or boolean variable which takes only 2 possible values without any quotation marks. It can be either true or false. Okay, so let's go back. So these are all examples of something that's called elementary or atomic data types. Okay, so all the data that we're going to be dealing with is either numerical, right here, okay, or text, string, a bunch of characters which are not limited to numbers, can be anything, or it can be boolean. Okay, true or false. All right, so all of these examples, my uppercase x, lowercase x, y, z variables, are the cases where I recorded a certain single value into the variable. Okay, so for example, x right now has the value minus 5.3, and that's it, nothing else, right? X has the value, the word hello, that's it, nothing else. Y is true, z is false. So each time when you are recording just a single value in a variable, such variable is called scalar. So what we just did is we defined 4 different scalar variables: capital X, lowercase x, y, and z. Why they're scalar? Because each of them holds only one single value. Let's take a look at something more involved. Okay, vectors. Vector is a collection of more than one value, but it goes under the same name. Okay, so let's do this one example. So let me switch back to the RStudio. Okay, and let me add a new line here. So we already used capital X, right? So let's be more inventive. Let me call it, I don't know, A, for example, right? So I'm gonna put the comment here, create a vector variable. I'm gonna use, no, let's actually use lowercase a, right? So this is just a comment. Again, reminder, right? This line is completely ignored by the program, so I can type whatever I want. This is really a documentation, a comment for me to remember what am I doing, right? So I'm gonna say a. This time around I'm going to use this arrow. So a is the name for the variable, and it points to the collection. Now I'm going to point to the collection of values, okay? And the collection of different values, or a vector, we can create using the function. This is going to be our first example. What is a function, right? A function which is called C, so one letter, C. And each function, it's just like Excel actually, okay? Each function takes a number of parameters, right? So just like what you were doing in Excel when you were calculating sum, for example, you type sum, and then after that open and close the brackets, right? So I'm going to do exactly the same thing. I'm going to start with a bracket, and because again R is fairly smart, knows that once I open the bracket, it has to be or parentheses, right? It has to be closed at some point. So it puts opening and closing parentheses and I can type pretty much anything I want in between. So let me go ahead and create a numerical vector. So a vector that has numbers inside of that. 2, 4, 6. Just like I believe what I have in this example, right? Yeah, 2, 4, 6. Okay. So I'm going to run this one. So again, you can either click anywhere on this line and click hit the run button, or you can just go ahead and hit Control Enter, and look what happened. Right here in the listing of all of my variables, I have A. That's the name of my variable, right? It's a pointer to the variable, and num says numerical, right? And one column 3 basically says that it has 3 values, 1, 2, and 3, and they are 2, 4, and 6. It has 3 values inside. So that's why it's called a vector. Okay, I am using one name, lowercase a, in that specific case, that points to 3 different values, 2, 4, and 6. We're actually going to use that a lot. We're going to do some manipulations with numbers. For example, we can calculate the average, standard deviation, median, all kinds of statistics about a collection of numbers, right? So this is where actually it's going to get useful for statistical calculations. And if I want to type out what's inside my variable a, all I have to do is say, show me the a, and again run it, right? I'm going to click the run button right here, and you can see that it types all 3 different values. It says your variable a points to the values 2, 4, and 6. Okay. So unlike our previous cases where we looked at numerical values, text or string or logical Boolean variables, each of them pointed to only one value, -5.3, true or false, right? Here the name of the variable a points to 3 different values simultaneously. Okay, so it's a little bit more advanced. Now I can actually look at individual values, and they are enumerated, right? Right here in the environment, you can see that their enumeration starts with 1. So 1 corresponds to number 2 because it's the first one in the vector. This one is number 2, value is 4. And the third element, number 3, is value 6. So if I want, for example, to take a look at the first element, all I have to do is say a, that's the name of my vector variable. And after that, I have to open square brackets, okay, not the round brackets, parentheses, but square brackets. I'm gonna say, show me the first element for the variable a, and that's going to be a 2, right? Because that's the first element of my vector. So let's go ahead and run this line. Yeah, right there. There's your 2 at the bottom. Okay. If I want element number 3, obviously it's going to be 6, right? So I go ahead and run it, and there's your 6. Okay. So this is how I access individual elements of the vector. Let me actually go ahead and type that as a comment. Access individual elements of a vector variable. Okay. So third element of vector a. Now this is an example where I have a vector of numerical values, right? So 2, 4, and 6 are all numbers. Okay, so let me give you an example of the variable, which is vector of strings. So again, I'm going to use the same function C. Oh yeah, and by the way, I forgot to mention that C actually stands, it's an abbreviation for combine. So essentially what C does is it takes number 2 in our previous example, combines that with number 4, combines that with number 6, and names all of that A, right? So C stands for combine. Okay, so here I'm going to combine 3 text values. For example, let's say I have a listing of my students in the class, right? So first student name is John, comma, second student name is Jane, and another one is Jennifer. 3 J's, right? John, Jane, Jennifer. So notice that I enclose each of the values inside the double quotation marks. That is supposed to show my function C that all the values are text values. So I'm going to run this line. You can see that there is a new record, right? So variable called B. CHR stands for character, right? So this is a vector of values which consist of characters, right? And again, 3 different values. You know what? Let's just go ahead and include Michael, number 4, right? Michael, right there. So now I run this line, and you can see that my B is updated. So character vector, but the values are from 1 through 4 because I have 4 elements, right? And these are the elements: John, Jane, Jennifer, Michael. Okay, so same thing, right? I can type out what's inside of my entire vector, or I can go ahead and say, well, show me the element number 3. And how do I do that? Square brackets, element number 3, hit Control Enter, and there it is. Element number 3 is Jennifer, because she is 1, 2 in the 3rd position inside of my vector. Okay. All right. So here, well, let me actually expand it, right? Create a vector variable, a numerical, right? A numerical vector variable A. So here I have created, again, #, right, for the comments, create a character or a string vector variable B.